Now we shift from how ZK systems work to where they matter in the market. Where do scalability, verification, and privacy create better products? We'll look at payments, identity, DeFi, gaming, social apps, and enterprise adoption. So far, we've built the core toolkit. Ethereum scales through layer 2s, ZK-rollups use proofs for efficient verification, and privacy requires intentional design. Now we'll apply that toolkit with a product lens. Where do these systems create real value, and what trade-offs shape adoption? Strong ZK and privacy use cases start with a real constraint, not a technology preference. If an application has lots of transactions, ZK rollups can make activity cheaper and faster while still settling securely to Ethereum. If the problem involves sensitive data, privacy tools can prove a claim without exposing everything behind it. The key question is, what becomes cheaper, safer, more private, or easier to use because ZK is part of the design? Payments are one of the clearest places to see ZK rollups in action. A stablecoin transfer on layer 2 can have low fees and quick confirmation, so small or frequent payments become more practical. The rollup batches many transactions, proves them, and settles back to Ethereum for security. That pattern can support remittances, payroll, creator payouts, and commerce. The best products will hide the crypto plumbing and feel like normal digital wallets. Public chains make payments easy to verify, but they also reveal a lot: who paid whom, how much, and often the surrounding transaction history. Private payment flows change that trade-off. A zero-knowledge proof can show that a transfer follows the rules without revealing every detail. The goal is not to hide everything forever. Good designs support selective disclosure, so users can prove facts to auditors or counterparties while keeping routine activity confidential. Consider two everyday payment problems: a local merchant waiting for card settlement and a family sending money across borders. ZK rollups can batch activity, lower network costs, and settle faster than many traditional rails. Privacy matters too, because payment data can reveal suppliers, revenue, and customer habits. The harder part is adoption. People still need reliable fiat ramps, simple wallets, compliance controls, and enough trust to use the system. Identity systems often collect far more information than they actually need. With zero-knowledge credentials, a user can prove one fact, such as being over 18, being a resident, or holding a valid membership, without exposing the full ID behind it. This supports access control with less data collection and more user control. The hard part is trust. Credentials need reliable issuers and real-world checks, without rebuilding the same centralized surveillance model. That same idea applies to practical identity checks. A service may only need to know, is this a real person? Is this user old enough? Or does this account hold the right credential? With ZK or selective disclosure, the service can get confidence to block bots, enforce age rules, or gate access without storing full documents. The design challenge is making issuers, revocation, and auditability work without turning them into hidden surveillance. Reputation is valuable only if applications can trust it. But public reputation can quickly become surveillance, where task history, payment behavior, and identity links turn into permanent signals. ZK credentials offer a different model. A user can prove they completed work, repaid loans, or earned contributor status without revealing the full trail behind it. The hard questions are governance questions: who issues credentials, how they move across apps, how revocation works, and how farming is prevented. DeFi's transparency is powerful, but it can be too revealing for serious finance. Public order flow, portfolio exposure, and trading behavior can all leak strategy. ZK and privacy systems create room for a different model. Participants can prove they are compliant, solvent, collateralized, or authorized without exposing every underlying detail. That can support private trading and institutional participation while preserving verification. The challenge is making sure confidentiality does not become opacity, especially where risk controls and market integrity matter. In finance, ZK proofs are strongest when the question is narrow. Is this condition true? A platform can prove assets exceed liabilities without revealing each customer balance. A protocol can prove collateral or exposure stays within limits without exposing the full position. A pool can admit only users with valid credentials without publishing their identities. But the proof is only as trustworthy as the inputs, issuers, and rules behind it. Zk reduces disclosure. It does not replace governance or audits. Public DeFi also turns execution into a signal. Mempools can expose intent, wallet histories reveal patterns, and visible positions can invite copy trading or targeted attacks. Privacy-preserving systems change that experience. The market can verify that a trade is valid, funded, and rule-compliant without seeing the full strategy behind it. The key trade-off is governance. Privacy should protect legitimate execution while still preventing manipulation, fraud, and sanctions evasion. Gaming makes the idea more tangible. Imagine a strategy game where players commit to secret moves, hidden cards, or fog of war positions, then later prove that every action was valid. ZK-rollups can keep frequent actions, rewards, and item trades cheap. A similar pattern helps social apps, where users can prove reputation or membership without exposing their full history. The result is interaction that can be safer, cheaper, and more user-controlled. In enterprise settings, zero knowledge is less about anonymity and more about controlled confidence. A company starts with sensitive business data, such as shipment records, certifications, or internal controls. It generates a proof or credential, then lets another party verify the required claim privately. Selective disclosure means only the necessary fact is revealed, not the underlying records. For high-volume workflows, ZK rollups can add scale while keeping Ethereum settlement assurances. The hard parts are integration, permissions, and acceptance. The main takeaway is simple. Start with the product problem, not the proof system. ZK rollups matter when scale and cost are binding. Privacy systems matter when confidentiality, identity, or selective disclosure create real value. Next, we'll turn these use cases into protocol trade-offs, adoption strategy, and a capstone evaluation.